Salt testing methods vary from simple consumer checks for purity and authenticity, like solubility and iodine tests, to precise laboratory techniques for food and surface analysis. Common laboratory methods include tetrametric analysis for chloride content, e.g., Mohs method, ashing for total sodium measurement, and conductivity meters to assess soluble salt contamination on surfaces via the Bresley method. Simple consumer tests. These tests help identify fake or adulterated salt. 1. Solubility test. Genuine salt dissolves completely in water, leaving it clear, whereas fake salt may contain impurities that make the water cloudy or leave a residue. 2. Iodine test. For iodized salt, add a few drops of iodine solution to a salt sample dissolved in water. A genuine salt will turn blue, indicating the presence of iodine. And 3. Potato test. Apply salt on a freshly cut potato surface. Applying a few drops of lemon juice after a minute will cause the potato to turn blue if the salt contains adulterated iodine. Laboratory tests. These methods provide quantitative analysis. 1. Titration methods. These are common for food analysis. Argentometric titration. Used to determine the chloride content by reacting it with a known concentration of silver nitrate solution. The reaction forms an insoluble precipitate, and the endpoint is indicated by a rise in potential or a color change. Mohs method. A specific manual titration using potassium chromate is a color indicator to detect the endpoint when excess silver nitrate is added. 1. Ashing. Involves heating a food sample to high temperatures, which converts the sodium in the salt to ash. The ash is then weighed to determine the salt content. 2. Elemental analysis. A direct method to measure the sodium content in a sample. Surface contamination testing. For assessing soluble salt contamination on surfaces. Bresley method, conductivity test, involves placing a water-soaked filter paper or patch, like the Defelsco adhesive patch or Posey patch, on a surface. The water absorbs the soluble salts, increasing its electrical conductivity. A salt contamination meter measures this conductivity to determine the salt level in micrograms per square centimeter.